Hello there, creators. Welcome to the third lesson on functions. So today we'll be looking at inverse functions of many to one quadratic functions, right? Okay. So we are still continuing with our series of inverse functions. So what you need to keep in your mind, as we did on the previous lesson, if you haven't watched it, please make sure that you do check it out, right? So where we checked on what exactly is an inverse function. So I won't be treating that. We'll be going on straight to what an inverse of a many to one quadratic function is, right? So now let us consider this function that we are given here, right? Okay, so we are given f at x, or f of x, is equals to x squared, right? So let me throw my Cartesian plane there. Okay, so I'm just doing a sketch here. So this will be my x-axis and that will be my y-axis. Right. So we have already been given the points as to what are the inputs and what are the outputs, right? Okay. So now let's plot this graph here. Okay, so the first one that is easier to recognize would be 0 is to 0, which would be somewhere here. Then the second one would be 1 is to 1, which would be somewhere around here. Then the third one here, negative 1 is to 1, which will be somewhere just here. Okay, so now let us draw this graph here, okay? So I just hope this comes out perfectly, okay? So now we have this function here, which is a quadratic function or a parabola, right? So when you draw it, it's not supposed to be, when it comes here, it must be, yes, right. It must be concave here. It must not take the form of a pyramid, right? Okay, so now we have this function here. So this is negative, this is 1 is to 1, and this is negative 1 is to 1. Okay, right. So now we want to draw the inverse function, or we want to produce the inverse function. So for the inverse, if we were to draw an inverse function, now we have learned that in an inverse function, what happens basically is that the x values become the y values and the y values become the x values, vice versa, right? Okay, so what was the x on the original will now become the y, and so on, right? So it means that basically what will happen here is that if we continue to have the same coordinates, negative 1, 0, and 1, 0, y, 1, sorry. So let me just remove that there, right? So that is 1. Okay, so what will happen here, it will just be a change of the x and y. Your y values will become your x values and x values will become your y values. Right, okay. So now these are the coordinates of the inverse. Now let us draw the coordinates of the inverse here. So the y will have a y at negative 1 and an x on 1. So negative 1 is to 1. So that will be negative 1 here, then 1 there. Right, okay. So that will be somewhere there. Then 0 is to 0, that will be here. Then 1 is to 1, that will be here. Right, okay. So it means that we'll have something like this. Right, then from there, okay, right. So you can see here that, okay, this looks funny. This looks like a funny function here. So now let us check if, is this inverse that we have here, is it a function? Right, okay. So, before we get there, all right, let us see, right, okay, will this be a function or not? Let us perform now the vertical line test. So you see that if we move from left to right, if we do the vertical line test, this will cut the graph twice, which would mean that this here is not a function. Why? Because this vertical line test passes this graph here twice, which makes it not to be a function. Now we are left with a dilemma as to, okay, now these people told us that they want an inverse function. But from what we see is that what we have drawn here, we are not producing a function. Right, so what do we then do in scenarios or cases like this? Now, this would come to us now restricting the domain of the original function. Right, so what is the original function? Here's our original function here. Let me throw it in black so that you don't get confused. So this is our f of x. Then this would mean this is our inverse, which is f at negative x. Or if you want to find the formula for this one here, you'd simply just do the same thing that we did here. So already you know that if we have f of x is equals to x squared, the first thing you need to do is to change this f of x and make it y is equals to x squared. Then what do you do after that? You interchange, right? What was x becomes y, what was y becomes x. So this would be x is equals to y squared. But now this looks funny, we can't have y squared, so we need to root both sides, right? So now that will mean y is equals to plus minus root x. Right, so this would now be your formula for the inverse. Now that means the inverse will also be represented like this, plus minus x. Right, okay, so I hope that you guys are following. So now let us come to now restricting the domain. Okay, so how do we restrict the domain of the original function? Right, so we need to cut this graph basically into two equal halves. The original one, look at the black one. So it will mean we need to cut it into this side only, then now cut it into this side only, so that the inverse functions will also be functions. Right, so if you're not following as yet, please continue to listen and make sure that you are attentive. Right, okay. So now let us come to the first part of restricting the domain. Okay, so the first one, let me throw a second one here so that you are not confused as to now how did we restrict this graph. Okay, so we still have our x and we have our y here. Okay, so now the first thing is to restrict the domain, or is to say, okay, we're gonna restrict the domain of the original function of f of x is equals to x squared, where x must be greater than or equals to 0. In other words, we are taking this part or this left or this right hand side part of the graph. So we are only considering this part now. So in other words, now what we have of the original graph would be this side. So we have restricted the original function. This is the first restriction, saying now where x must be greater or equals to 0. So you know x must be greater than or equals to 0. This is the part we're talking about here. So meaning now we have taken out this other part a bit. So let me throw it like that so that you see that in a way it's still there, it's just that we have restricted it. Okay, so now what is the important thing when it comes to the inverse of a quadratic function? Always make sure that the inverse or the range of the original function must be the same as the range of the restricted function. So let's check that. Here is the original function. What is the range? The range here is, okay, you see y is from 0 up to positive infinity. So the range here, it's y must be greater than or equals to 0 as well, right? So let us check, is that the case for the range of the restricted function? Let us check. Oh, yes, it's the case, because the range is also running from 0 up to positive infinity for y. So it means that the range here is y must be greater than or equals to 0. Then now when we do this, automatically it makes the inverse of this restricted function to be what? To be a function. So it means that we can't make a many-to-one inverse function. So for a many-to-one inverse function to be a function, we need to restrict what? The original function or the domain of the original function, such that the inverse also becomes a function. I hope that I'm not confusing you guys. Please make sure that you are not confused, because this is very, very important. Right. So now what would be the formula for this one here? So we have already stated that, okay, the inverse would be equals to plus minus x, the root of x. So now how do you know which one is the formula for this one? So already this one tells you that, okay, the domain or this graph exists only where x must be greater or equals to 0. So if you remember your grade 11 work, you'd know that under a root, so if you would find the equation of this one here, you know that under a root, x must always be positive. X always must be positive. It must be greater or equals to 0. Because immediately when you say less than 0, therefore it will become what? An error. So you're gonna get a non-real number. You can try that in a calculator and put a negative number inside of a root. You're gonna get an error, right? So for us, or for this equation to exist, it means that since we have our x's running on the positive side, it will mean that f of x will be equals to root x, which is the positive one, since we have a plus minus. Therefore, now we also restrict to say where x must be greater or equals to 0, and y as well must be greater or equals to 0. Right. I hope that this, guys, makes sense and I'm not confusing you at all. So now this is the first part of the restriction of the inverse function of a quadratic function. Right. I hope that this makes sense. Now, follow me as we check the second part. Okay. So, let me just quickly take this thing off here. Let me take this part only. So now we are done with where x must be greater or equals to 0. Okay. Now let us deal with the other part. Right. So I'm still going to have my Cartesian plane. I'm still going to have my Cartesian plane here. X, Y. Okay. Then now remember, we are now restricting the other part. So now meaning we are dealing with x must be less than or equals to 0. So now we are restricting the graph to x being less than or equals to 0. So x being less than or equals to 0 is from this part here going this side. So it means now we are now focusing on this part only. Sorry about my graph there. I know it doesn't look very nice, but please make sure you're just following with the concept. That means now we have left this other part here. Okay. Right. Hope that you guys are still following. Right. So now we have restricted the graph to this part here. So what was the principle that we talked with on the previous graph? Is that the range of the original graph here must also be equals to the range of the restricted function or the restricted inverse. No, not the restricted inverse, but the restricted graph. Sorry. Right. So now you can see that the range from here is from 0 to positive infinity, and the range as well here is from 0 going up to positive infinity. So we are good to go. So the restriction now is okay. We can move on now to finding what is the formula. Right. Okay. So it means that now the inverse, if this was a positive or a negative 1 is to 1, it will mean that the inverse here would be the one of 1 is to negative 1. So the 1 is to negative 1 is the one that goes here. So now this would be the inverse, right? So now this will be the inverse function where x must be less than or equals to 0, right? Okay, so now again, how do we find the formula? So the formula, still we are here. So f at negative 1, x is equals to plus minus the root of x, right? So remember, we are saying that here x at any point must not be a negative. So now we see that we have taken the part where x must be less than or equals to 0. Now that means we will be taking the negative 1 now, which will be equals to negative root x, right? Okay, so now again, you're not done. You must restrict the x values, because if you just let it to be any x values, you might find yourself with an error on your calculator. So what will make this not to be an error? So always make sure that your x must be greater than or equals to 0, right? So that is the first part. And on the second one, your y must follow your x. So your y must be less than or equals to 0, right? So you see, for the inverse to exist, your y must be below the below the x axis, so that it's on the negative y's. So that is why we are saying that your y must be less than or equals to 0, and your x must be greater than or equals to 0, right? Okay, so it depends on how you want to look at it, in terms of the graph or the inverse graph, or in terms of the numbers here, knowing that your x here must always be a positive number, right? Okay, so I hope that this, guys, was very helpful to you, and that you learned a lot, and in terms of now you knowing what a inverse function of a quadratic function is, right? So the key point that you had to grasp here was that for a quadratic function, you'll never find a many-to-one inverse function. So you must always restrict the domain of the original graph such that you'll have the inverse now being a function, right? So if you guys didn't understand along the way, make sure that you paused and you listen to it again and again. So guys, please make sure that you subscribe to the channel so that we make it grow, and share the videos to others who you see that they might be helped with such videos. So continue to follow us, guys, on all our social media platforms. Thank you. Join me next time when we deal with the inverse function of exponential functions.